All right, friends, it's your boy, Mr. Shiny, coming at you with Unit 3, Lesson 3, Making Scaled Copies. So in the past 2 days, we've developed this definition of a scaled copy, understanding that when we take an original, if we multiply the original by a number, it's going to give us a scaled copy that can be either larger, smaller, or even the same size. We found out yesterday that a scaled copy from our original figure will have the same angle measures as well. And so we're taking this and we're developing some more skills today. So we're going to be, the first activity is asking us to build some of our math knowledge and use our math knowledge in some practice. And so our first warm-up today is basically, this is like a warm-up just to get us thinking about what happens when we multiply a number by a larger number, and then what happens when we multiply a number less than 1, and then what happens when we multiply two decimal numbers together, what happens to our answer. So we're really looking at that. So this says more or less. For each problem, select the answer from the two choices. So it says the value of 25 times 8.5 is more than 205 or less than 205. I'm going to break this down. So I'm going to take 25. I know that 25 times 8 equals 200, right? That's part of my product. So that's called a partial product. And then I'm going to take, so I've done that part, then I'm going to take 25 times a half, and I'm thinking about what is half of 25? Well, half of 25 is 12 and a half. And so if I combine these two things together, 200 plus 12 and a half, that gives me 212 and a half, which is more than 205. So we're really thinking about this in terms of using our math sense. So this is called a partial product. Another way you can use this is you can do the standard algorithm. So this is called the standard algorithm. And so you could just do 25 times 8.5. You multiply like normal with the standard algorithm. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12, add a placeholder, 8 times 5 is 40, 8 times 2 is 16, plus 4 is 20, that's 5, 2, 1, 2, and we move the decimal one time, so it's 212 and a half. Now, either way will get us the answer, doesn't matter how we use it, so this is the traditional standard algorithm, this is called a partial product. In question 2, it says the value of 9 93/100ths times 984 thousandths. Now, we could do the standard algorithm here, so we could set it up. So what I would do is I would take 984 thousandths and I multiply that by 9 93/100ths, right? And know that this would be 3 times, this would be 2, so you need to move your decimal 5 times. Or I could think about this number and use some sense that I have. So I know that 993 hundredths times 1 whole will give me 993. So if I'm thinking about it that way, right, we know that 984 thousandths is less than 1 whole. And because it's less, we know that our answer, so if this is 1 whole and this is less than that, we know that our answer is not going to be more than 10, but instead it's going to be less than 10. So if we're using our reasoning there, that will work. I'm going to check my work over here, so I'm going to apply the standard algorithm. 4 times 3 is 12. 8 times 3 is 24, 25. 9 times 3 is 27, 28, 29. I'm not going to apply that 0. I'm going to move on to the next place, so I add a placeholder. 9 times 4 is 36. 9 times 8 is 72, 73, 74, 75. 9 times 9 is 81, plus 7 is 88. And then I do have to apply here. So that's 1. I might have made a mistake, so I'm going to check my work again. 4 times 3 is 12. I might have skipped something. 8 times 3 is 24, 25. Okay, perfect. 9 times 3 is 27. 28, 29, so that is 9. And then you put the 2 here. 3 times that is that plus the 2. So the 29 does still go there. So I just want to make sure I check my work. Then placeholder, 6. 9 times that is 36. Then we have 9 times that is 72, 75. Then we have 9 times 9 is 81, plus that is 88. 9 times that is 0, plus 8. So it should be 88 there. Then I'm going to add 2 zeros. This is what happens when you do all this work, so sometimes it's easier to reason through it. And then 9 times that is 36. And it gets confusing up here with all those numbers. 9 times 8 is 72, 75 again. So 5. 9 times 9 is 81, that's another 88. So then we have 2, 11, 10, 15, 16, 17, 18, 19, 20, 21, 10, 15, 16, 16, 17, 9, which it should be smaller than it currently is, so that looks good, and we're gonna move it 5 times, so 1, 2, 3, 4, 5. So 976, 9 and 76 are 9.76112 is how we would say that number. We could say it place value wise, but that would be kind of difficult. But in this one, this makes most sense because it's going to arrive at our answer fastest route, which is thinking. This one, it's a tried and true process, sure, but it's a lot of extra things to remember, and you can easily make a mistake if you don't go back and check your work. So the value of 24 hundredths times 67 hundredths is more than 2 tenths or less than 2 tenths. Well, I know that this is originally, this is 100th times 100th. And we're talking about place value here. 100th times 100th. And I'm going to use some logic here. So I know 100, like 100, times 100. That's 1, and then 1, 2, 3, 4 equals 10,000. So 100th times 100th is a 10,000th. Right? So I'm using that logic. So here I can set up my standard algorithm. So I can do 24 hundredths times 67 hundredths. Know that I'm going to move my decimal place a total of 4 times in my answer because there are 2 numbers that appear after the decimal point there and also 2 numbers that appear there. I'm going to multiply like normal. So this is my standard algorithm. That's 28. And now I notice that you can't see what I'm doing. So that is 28. 7 times 4 is 28. 7 times 2 is 14, 15, 16, 168. Add a placeholder. 6 times 4 is 24. 6 times 2 is 12 plus 4 is 14. That's 8, 10, 6, 1. I'm going to move it 4 times. So that is barely 16 hundredths. And so that is less than 2 tenths, right? So it's not less, so it's less than 2 tenths. So this will be what my answer is. And I want to make sure I check my work. So 28, that's 28, 14, 15, 16, perfect. Add a placeholder, 24, perfect. 12, 14, perfect. 8, 10, 6, 1. So you could do it like that. Another way to reason through this is to think like 2 tenths is 1/4 of 8 tenths. And currently 8 tenths is greater than that. And this is not even 25 hundredths, but I would say the best method for this answer is probably your standard algorithm, because the thinking that they want you to do here is a little too much. So I think the standard algorithm is the best method. So for the first one, I think a partial product works best. For the second one, I do think that the fastest route is thinking about, so what happens when you multiply a number by a number less than 1, like what happens to it. And then this one here, I think the standard algorithm makes the most sense. So we're using that to help us develop sort of the thinking patterns that need to be established in mathematics whether using a partial product, what happens when you multiply by less than 1, and then your standard algorithm. So that's in our first activity. I know that took us 10 minutes, but it's perfectly fine. It's not about speed, it's about thinking about that. I will say that your grid here is a little rough, but you are going to be picking, it says draw a scaled copy of either figure A or B using a scale factor of 3. So what we're going to do is we're going to measure the sides. So I'm going to choose A. I know that side is 2, this side is 3, this side is 3, and if I elaborate, this side as well is 3, but it's on that curve, right? And so they said a scale factor of 3, meaning that I'm going to multiply each one of these sides by 3 to get my new sides. So I'm going to redraw this. So that's 1 cube, 2 cube, 3, 4, 5, 6. That's the top. 1, 2, 3, 4, 5, 6. That's the side. 1, 2, 3, 4, 5, 6. That's the base. Oh, and I already messed this up because I did too much at the top. So that is not needed. It's supposed to be 4. All right. No, I messed it all up. Oops. I didn't multiply by a scale factor of 3. That's my problem. So the first part is 6. I just recognized that I just did it wrong. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to be doing this at a curve. And what I'm going to use is I'm going to use my index card here to connect these two lines. So I can make a straight line between them at a curve like that. And so this side should be 6, this should be 9, this should be 9, and then this height, when I measure it, should be 9 as well, and that's the scale factor. So I just did A. So my brain was working too fast there, so I apologize to my friends where I started out thinking wrongly because I thought all the sides were 2, and I apologize for that. So that's what it should look like. Whenever you need a straight edge, you can use an index card. I will give you some index cards tomorrow to take home to help you with your homework. You don't necessarily need a ruler. You just need to be able to use an index card or a line sheet of piece of paper. Now we're going to draw a scale copy of either figure C or D using a scale factor of half. So we're going to cut it in half. I like D. D is interesting. So I see that this is 2. This is 2. This one it's going 2, 2, 1, 2, 3, 4, 5, 6. That seems like 6. 1, 2, 3, 4, 5, 6. So we're going to cut it in half. So cutting it in half would be, the bottom of that would be 3. 1, 2, 3. From there, we're going to cut that. Well, I want to make sort of the top. So we're going to go up 3 at a curve. So we're going to go up 1, 2, 3, and right there, 2, 3, and there we're going to make 1. I'm going to connect these two lines like this using my index card, just like that, and then that's 1, and then it's going to go up 1 square like this, and then it's going to go across 1, and then it's going to go down 1 using this index card here. And I think that none of you could see what I just did. So I got my image, I used the index card to make the lines here by basically measuring one segment and another and connecting them, and then using the grid to kind of help me get the rest of that. Right, so these two activities here is basically we pick one, we scale it by a scale factor of 3, and then we cut it in half. So this should be 3, this should be 3, this should be 1, 1, 1, 1. And that's the idea. And it looks like my mind does not look as sharp. there, so maybe I didn't cut it right there. My bad there. So my 2 doesn't look as perfect, but you get the idea. This one says which operation. So it says Charlie Hughes and Aubrey Robinson want to scale this polygon so that the side that corresponds to 15 units in the original is 5 units in the scale copy. So this is where they're talking about. This needs to be 5 units. So what is happening to go from 15 units, 15 times what number equals 5? So we're really trying to understand that. Well, in order to undo multiplication, we're going to divide by 15 on both sides. I can simplify this fraction. That will give me my answer. So I know that I'm technically, that's 1/3. I'm multiplying by 1/3, or I'm cutting it into, 3 equal parts. So you have 2 different drawings here. You have Charlie's, which, is not even connected anymore, and then you have Aubrey's. So in the back it says, what operation do you think Charlie used to calculate his drawing? Well, from here to there, it doesn't look like he divided, right? Because then this is 26, this is 8. It looks like what Charlie did is Charlie subtracted each side by 10. So Charlie subtracted each side length by 10. And so that's how he got every number, and you could say, 26 minus, or 36 minus 10 is 26, 15 minus 10 equals 5, and so you kind of get the picture there of what that's saying. What operation do you think Aubrey used to calculate the lengths for her drawing? So we did the math at the top. So Aubrey looks like what she did is she multiplied everything by 1/3, or she divided everything by 3, because multiplying by 1/3 or dividing by 3 is the same thing. So what Aubrey did, so Aubrey went from 15 to 5 by multiplying by 1/3 or dividing by 3. Did each method produce a scaled copy of the polygon? Explain your reasoning. So Aubrey's method produced a scaled copy because each side was multiplied by the same scale factor of 1/3. Right? On the other hand, right, so I know that some of you are missing some points here. On the other hand, Charlie's method did not yield a scale copy because subtracting the same number did not produce even a polygon. So it's not even a copy of anything. It's not even a polygon, so it can't be a scaled copy of a figure. So that's what we have there, right? So moving past this, we're gonna get to our last thing, and we're gonna look at which operations part 2. So Henry wants to make a scaled copy of Tallulah's drawing so that the side that corresponds to 4 units, so he's talking about this side here, and Tallulah's polygon is 8 units. So he really wants, so he's going from 4 to 8. To go from 4 to 8, we know that our scale factor has to be times 2. Right, so that he has to multiply each one of these sides by 2. So first Henry says, I wonder if I should add 4 units to the length of all segments. What would you say in response to Henry? Explain or show your reasoning. Adding, so to Henry, I would say adding 4 units would not work because the shape of the copy would be different than the shape of the original. Okay, and so now it says create the scaled copy that Henry wants. So what we're going to do is we're going to take an index card. So you're going to receive an index card. And what I'm going to do is I'm going to measure sort of that side length. So, and if I wanted to double it, I'm thinking, like, how could I do that? So if that's 4, and I want to maybe start this toward the bottom and give it some space. If that's 4 units, then what I'm going to do is I'm going to draw a line, straight edge. I'm going to take it up where the index card meets that again as perfectly as I can, and I'm going to double it just like that. So that's going to be my 8 units, right? And now I know I'm going to go 5 across. I know that some people cannot see because this is not conducive to that. So that's my 8 units. All I did here, again, I want to reiterate what I just did. So I measured the original, that's where 4 is, and basically I drew a line and then I doubled that line. So now I'm going to do the same for each side. So I'm going to go back up here. I'm going to measure this. This is a little further. It looks like maybe I'm off there a little bit. I want to measure it with a different side so I can actually not be off there. So that's 5. I'm going to double that length. And the thing is that you're going to have human error here, so it's not about perfection. It's just basically understanding that basically you are doubling what this figure looks like by drawing it out again. That's what we're trying to get at here. So all the people that are looking for perfection, really, let's not hope for that because it's bound to have some human error. We can't all be perfect people. And then so this is the next line I need. Can't all be perfect. So that's my 12. And I'm going to double my 7. Trying to make this as easy as I can. So I'm going to double my 7. You see I measured there. Double my 7. This is my bottom. So, boom. Boom. That's my 14. And then I'm going to do my 12. I'm going to measure up here again as perfectly as I can. I might even give you all some tracing paper just to make this a little easier. So I'm going to go over. And I'm going to do that again. I want to bring that down so that you can see what I'm doing. I apologize that this is kind of a hot mess. And you see that there. And then basically from there, what I'm going to do is I'm going to take my sort of straight edge and I'm going to line those up perfectly like that. And so this should be 20, this should be 24. And so that's kind of how you make a scaled copy with an index card, because we're basically just trying to understand how we could, so the whole concept here is what operation. We're doubling it or we're increasing the size by 2, and to do that we can take an index card or a sheet of paper and basically measure and then just times that by 2, which means do it again, right? You could do that to multiple things. So that's what we're looking at for tomorrow. I hope you enjoyed this video. I apologize for its length, and I will see everyone in class tomorrow.